Okay, welcome everyone to another YouTube video on my YouTube channel. So today I'm back with another mathematics question. The question says ABC triangle is right angled at B. M and N are midpoints of AB and BC respectively. Find the value of 4 brackets AN square plus CM square. So for this we have to first draw the triangle, so I'll do that real quick. Okay, so I've drawn the figure, and now we can see in the question they've asked us to find the value of an squared and cm squared. So in order to find the value of an squared and cm squared, we'll have to first connect these 2 points, an and cm, so that we can find their values in the very first place. So here we go, we're just connecting these. And here we go. So now we can see that there are 2 triangles we've obtained, ABN and MBC. So now as we can see, there's a common angle B in there, which is 90 degrees. And by the Pythagoras theorem, we know that a squared plus b squared is equal to c squared. This is a very fundamental theorem of Pythagoras theorem we know. And now we're going to apply this and use it to solve our question and find the values of an squared and cm squared. So now in this triangle ABM, we can see that ABM triangle is right angled at B. So this is the hypotenuse, this is the perpendicular, and BN is the base. So we can write AN squared as AB squared and BN squared. Remember that. And now in this triangle MBC, we can see that it's again right angled at B. So MC is the hypotenuse, MB is the perpendicular, and BC is the base. So now we can write MC squared or CM squared as MB squared plus BC squared. So now we can see that AN squared plus CM squared is given in the answer to be found. So now we can simply add these 2 expressions. That gives us an squared plus cm squared is equal to ab squared plus bn squared plus bc squared plus mb squared. Now you can see that in the original triangle ABC, it is right angled at B. So now we can say that the opposite side in the side of the right angle is the hypotenuse. So AC is the hypotenuse. So AB squared plus BC squared is equal to AC squared. And now in our expression, you can see that there's an AB squared and BC squared. So if we add these 2 expressions, we get an AC squared. So we can rewrite this again as follows. AB squared plus BC squared gives us AC squared plus BN squared plus BM squared. Now you can see that M and N are actually midpoints of AB and BC. So we can write BN is basically just the half of BC and BM is basically just a half of AB. So we can rewrite these as BN can be written as BC divided by 2 and BM can be written as AB divided by 2. So now if we rewrite this entire expression, we get AC squared. Now BC upon 2 in whole square brackets, so that gives us BC by 2 whole squared plus AB by 2 whole squared. So now doing a little more simplification, we get AN squared plus CM squared gives us AC squared plus BC squared by 4, 2 squared 4, and AB squared by 4. Now we can see that the denominator here is 4, and that matches with the thing which is to be multiplied here, and we can see that we are getting closer to the answer. So now what we simply have to do is we have to multiply AC by 1, because AC squared by 1 is actually AC squared by 1. So we multiply the denominator with 4 to get 4AC squared, so that we can add all these expressions together. That gives us AN squared plus CM squared 4AC squared plus AB squared plus BC squared by 4. Now we can see that we again got AB squared and BC squared, and we already know that AB squared BC squared is AC squared. So adding these expressions, we get gives us 5 AC squared upon 4, and we need to find 4AN squared by CM squared. So we just transpose this 4 on the other side. Hence, the value of this expression 4AN squared plus CM squared is equal to 5AC squared. This is our final answer.